make features engineering and create our new insights from screen time data. As you can see, we in our previous video we make different visualization using our data set. We have the data set of screen time.csv file. Hope you download this csv file in your computer, and we also do that I am doing. Follow along my videos. You can also do features and feature engineering in using this data set. So let's start with feature engineering and what we will cover. So first of all, we will cover the identifying relationships between the different variables. We will also see the we will also create a new feature based on screen time patterns. And third, I would say we will also cover encoding categorical data for machine learning. So first step would be checking relationships between the features. So for improve our analysis, let's check how different variables are related. So for that we need to we need to write it down, import cbon as SNS, import matplotlib. I know we already done this matplotlib, and we already import this file, but if you do, that's also good practice that we can also do again. There is no harm in that. So for that, checking correlations, plt dot figure fidge dot size is equal to 8 and 5, close this parenthesis, and sns dot our heat map. We will create a heat map here, heat map. In that df dot error, if the df dot, let's say correct, because we want to see the correlation. So and we will create a function here, and not is equal to true. Also cmap is equal to cool warm, and fmt is equal to dot 2f, and line width is equal to 0.5, and we will give the title correlation between our features, relation between features. So by this way you can see the different age, gender, screen time, and all the correlation between the features. So next we can create a comparing a screen time usage by gender. So let's compare how screen time differs between the males and females. So for that we need to import our cbon matplotlib. If you don't want to import, you can if you don't want to, don't create that. So let's say plt figure fidge size is equal to 8 and 5, close this parenthesis, sns dot box plot. We want to create a box plot here. X is equal to df. In the df we will add the gender, y is equal to df average screen time hours, and palette is equal to set to. Now we can also adjusting our labels. So for that we need to add plt dot xticks 0 and 1. Use like a df, uh, let's add female and male, female and male. Plt dot x label, we can add gender. On y side we can also add uh, average screen time, and title we can also give comparing of screen time usage by gender, and then we can see the plt dot shows the comparison of screen time usage by gender, and on the left side we can see average screen time hours, and the difference between the comparing with female and male gender. So in this way we can see the this comparison, and let's try to understand the screen time trends for weekends and weekdays. For that we have to add new column here, new cell, and we can write dot plt dot figure, and in that fig size is equal to our 8 and 5. Also sns dot bar plot x is equal to df day type, y is equal to df average screen time hours, and after that we can use palette is equal to blue, and we can also adjusting our labels. For that we can add plt dot xtricks ticks, and in that 0 and 1. Weekdays, let's say first of all weekend and then weekdays. You have to specify the for plt dot x label, and in that we'll add day type, plt dot y label, and in that average screen time hours, plt dot title, and in that we will give the title of screen time trends of weekdays days versus weekends. And now we can see our plot. As you can see, we have the closing parenthesis error, syntax error does not match opening parenthesis. So in the second line it shows the error here, and after hours we have to add one uh, parenthesis. Now it must be run. Let's try to run this code. As you can see, we have to remove this also. Now it will give the again one more error. So in this time attribute error figure dot set is got an unexpected keyword argument which words fig size. So for that, okay, we have to remove this w, and now we can run this code. As you can see, we have the output here. uh, on the weekends, we see the average screen size, screen time, less compared to weekdays. So this is the way we can see the screen time trends for weekdays and weekends. So bar plot shows the like average screen time for weekends versus weekdays, and it will help us to understanding if people spend more time on screens during the weekends or not. So let's understand another pie chart. So let's try to write different. Let's see. I want to see the most common screen time type. So for that we need to make one screen time counts is equal to df, and in that we have to add screen time type dot value counts, and then we create a pie chart. So for that, plt dot figure fig size is equal to 8 and 5, as we always use fig size as an 8 and 5. Also plt dot pie and screen time. As you can see, we have the screen time counts. So let's just copy this and paste here screen time, and also we will add a labels is equal to screen time count dot index auto plct is equal to 1 dot 1 f modulo, and also after that comma and colors. We will add the colors here. There colors is equal to sns dot color and palette. So we can add one color, pastel color, I would say. And after that we can also adjust our title. So for that, plt dot title most common type of screen time usage and plt dot show. As you can see, we have the invalid decimal literal, and so we have the error here, and okay, we have to add one double quote here. Now we can run this code. As you can see, we have the pie chart, most common types of screen time usage, 33%, 33%, 33%. So this explain that pie chart like shows which screen activities, social media, work, environment are most common. So it will also help us to where people spend most of their time. So these was the all the three features engineering in our uh, video.